Hello everyone, welcome to DPS Siliguri online classes for class 12 for physics. Myself, Somnath sir. Okay, so especially today I discuss few topics related to your last class. The first topic is electric lines of force. So what do you mean by electric lines of force? See, from the previous class we know that force is equals to charge into electric field. Why? Because electric field is force by charge particle. So what is the definition of electric lines of force? In presence of electric field, suppose we introduce a positive test charge particle. So what happened? Force applied upon the charge particle, and due to which the particle is in motion. So when the particle is in motion, so it creates a path or locus. That path or locus is called electric lines of force. So what is the definition of electric lines of force? Force in presence of electric field, if you introduce a positive test charge particle, force experienced on the charge particle due to which the charge particle is in motion, the locus created by the charge particle is called electric lines of force. Now, on the basis of that, very important for your board exam as well as for your entrance exam, the first topic is properties of electric lines of force. Properties of electric lines of force. So what is the first property of electric lines of force? See, if we draw graphically, or if you want to say it here, if we have two charge particles, one is positive, one is negative, what we find? Electric lines of force appear to start from positive charge particle and terminates at negative charge particle. So what is our first property? Electric lines of force appear to start from positive charge particle and terminate at negative. The second property is electric field lines always tangential to the electric lines of force. Electric field lines always tangential to the electric lines of force. So suppose this one is your electric lines of force, and if you consider here 1, 2, 3 points, let it be A, let it be B, let it be C. So electric field at A is this, electric field at B is this, electric field at C is this. So what you can say? Electric field lines are tangential. Very simple. Third property, if you intersect two electric lines of force, what happens? At the point of intersection, you have two directional electric field. Let it be 1, let it be 2. But we know electric field is a vector quantity, and as electric field is a vector quantity, so for a particular point you have a particular one direction, so two direction is not possible. So the third property is that two electric field lines never intersect each other. Why? If they intersect, at the point of intersection we have two directional electric field. In practical, which is impossible. So which is not possible. Now the fourth property, electric field lines are continuous, smooth. Electric field lines are continuous, smooth, and without breaks. Means it will be continuous, smooth curve, no break. Like this, no breaking position is there. So it is a continuous, smooth path. Are you getting my point? Now the fifth property is, suppose This one is your electric lines of force. So if you see it properly, what you find in these two positions, electric field lines are very close to each other, and in this position electric field moving away from each other. So if electric field lines moving away from each other, that means that is the weak zone, means the electric field strength is weak. And here it is very near to each other, so electric field is strong. So what is the property? Property is that if the electric field lines moving away from each other, electric field strength decrease, and if they are moving close to each other or moving very close to each other, then electric field strength increase. So on the basis of that, so many 1 marks question even possible. Like see, if we have 3 points A, B, C. So A and C, they are nearly same type, but at the B, as they are in very large, the separation is very large, so here the field strength is weak. So we can say electric field at A nearly equals to electric field at C, which is greater than electric field of B. Next property is that for a metallic sphere, for a metallic charged sphere, like this metallic charged sphere, it's not a ring, it's a sphere. So it's actually a 3-dimension, but in 2-dimensional board it look like a circle, but it's a sphere. Okay, inside the metal electric field is 0. Inside the metal electric field is 0. That is one more property. Another property is that electric field lines enter or leave depend on plus charge or minus charge. If it is plus charge, then leaving. If it is a minus charge, then entering. Electric lines enter or leave normal to the surface, and that normal to the surface is very, very important. That means suppose we can show it like this. Now for here, this is the center, so how it will look like? It look like a curve. It look like a curve. So that means, what do you mean by that? That means it will be entering or leaving normally, and as it is a positive, so direction is away, means outward. So these are the properties of electric field lines, which is very, very, very important, and you can say also these are coming soon in your board exam. Next is that again so many very, very important question in board exam the examiner can arise. The first one is draw. Now we have to draw electric field lines. So first we have to draw electric field lines for point charge particle. So the question is like that, to draw electric field lines for point charge particle. So suppose we have a positive point charge particle and we have a negative point charge particle. So for positive point charge particle, direction of electric field lines moving away, means it will appear to start. Now for negative one, it will be moving towards the charge particle. So you understand what is the basic difference? For plus charge, the direction is away. For minus charge, the direction is towards. That is the first one for positive charge, this one for the negative charge. Now, suppose we have a pair of charge particle. So in pair of charge particle, basically pair means one is positive, one is negative. But here we consider as pair means one is positive, one can negative. Both can positive, both can negative. So if we first suppose the first one is positive, one is negative, and with a very small distance, this one is called dipole. Di means two, pole means two pole. So here the direction of electric field lines plus to minus. From this, you can say one more property, कि electric field lines never make a circle. Why? Because from plus it never make coming to this one, so it will be starting from plus and ended at the minus, so it never form a circle. Okay, or circular. This is the for plus and minus. If you have two positive charge particles, similar charge ripple, so we can say this one for the similar charge ripple each other. So this one is, you can say, neutral zone. And if you convert this plus into minus, if you want to convert this plus into minus, suppose you convert this plus into minus, or we can draw for minus also, no problem. Everything is same, except here you moving away, here it will be moving towards, because they are negative. You understand? Next is draw electric field lines for infinitely long line charge particle. So suppose we have infinitely long line charge particle, and suppose lambda is the linear charge distribution. That three type of distribution already discussed by Sujit sir. Three type of distribution of charge particle is there. One is the linear charge, second one is the superficial or surface charge distribution, third one is the volumetric charge distribution. In linear charge, total charge, in simple total charge per unit length, in surface superficial or surface charge distribution, charge per unit area, and in volumetric charge per unit volume. So this one is the linear charge. So here, if you see the electric lines of force, they look like this. And one very important thing, it's a 3 dimension, and here we draw it in 2 dimension, so we represent it in that way. But if you see it, suppose this is your line, so this charge can be possible in this side, this can be possible in this side, this can be possible in this side also, but as we have 2 dimension, so we are restricted in the 2 dimension plane. So this is our 2 dimensional case. And here, if we want to calculate the value of the electric field, we get lambda by 2 pi epsilon naught r, and we solve this when we go through that Gauss's theorem. Then we solve this all the values, and you can understand in better way, and from where you get this value. Now you just remember the value is equals to lambda by 2 pi epsilon naught r, and as it is inversely proportional to r, so we can say this electric field is non-uniform. What do you mean by non-uniform? It is not uniformed, means it inversely proportional to distance. Now see what happened in board exam. Now, as you know, in board exam class 12, 20 marks objective question is there. So examiner can ask you so many objective question, and they just say you it's a high order thinking, means HOTS question. So which type of question they can ask you? Like they can say to draw electric field versus distance or position graph for infinitely long line charge. So it's a very simple. See, E is inversely proportional to R, and as E is inversely proportional to R, we know the graph is hyperbolic. What do you mean by hyperbolic? If your distance is increasing, electric field is decreasing. If your distance is decreasing, electric field is increasing. You can say distance or position, means from this charge particle, if your position is increasing, electric field is weaker, or strength is decreasing. If it is very near to this, electric field is stronger, or field strength is increasing. Now this is one question examiner can ask you. Another question examiner can ask you, draw the electric field lines. Third question they can ask you, what is the value of electric field in terms of linear charge distribution. So how many questions you have? 1, 2, 3. 3 questions you have. Now one more question which is very, very important. They give you that graph, they give you that figure, and they give 2 points A and B. These are very, very important questions, especially for your board exam. Remember, this is a very, very important board as well as entrance exam. So you have 2 position A and B. Now suppose Q charge is moving from A to B. Q charge is moving from A to B, or you can move that charge particle from A to B. The question is that compare or where the force is higher, where the force is lower, or compare the force between A and B. They can give you some distance also. So which type of question they can, so many type of question they can ask you. Like first one, what we can say, suppose this distance is R1, this distance is R2. So we can say R2 greater than R1, or they can give you this one is R, this one is 2R. So you understand, let it be 2R, R2, let it be R1. So R2 greater than R1, E is inversely proportional to R, so E2 less than E1. Now E2, if you multiply with the charge particle, so we have force, so F2 greater than F1. So F1, or you can say F B, FA. You can write BA because we are giving here B and A. B and A. We can write it B. We can, sorry, A. We can write it B. See, so this is the question number 5. And now the 6. Suppose they ask you this distance is R, this distance is 2R. What is the ratio of their force? So now we know the force of B by force of A, or force of A by force of B, BQ by EA. So B, it is inversely proportional to distance. So what we write? 1 by RB by 1 by RA, because they are inversely proportional. So RA by RB. Now RA is how much? RB is how much? 2R. So what you have? 1 by 2, or you can write 1:2. So you understand, from one question, one topic, how many question examiner can arise? 1, 2, 3, 4, 5, 6. 6 question, 6 type of question they can arise. Now this is the line chart. Next one is infinitely long sheet. So next one is infinitely long sheet. In infinitely long sheet, we have a sheet like this. Sigma is the surface charge distribution. Sigma is the surface charge distribution. I can give you one example. Suppose this one is your sheet. So if this one is your sheet, so you have this one resin, this one is another resin. So how many resin you have? 2. And positive charge is here also, positive charge is here also. So for this portion, electric field is this direction, and for this one, electric field is in this direction. So how can we draw it? So this one is your electric field lines for infinitely long sheet. Sigma, what do you mean by sigma? Sigma is the surface charge distribution, that is charge per unit area. If you want to write the SI unit, coulomb per meter square. The last one is coulomb per meter. Now see, this is one question. They can ask you, draw the electric field lines for infinitely long sheet. You can draw it. Now the second question. What is the value of electric field? So this one is sigma by 2 epsilon naught. Now how you get this? How we get this one? So again, we can explain it later on the Gauss's theorem. But if you notice it here, what you find, no position is there. So that means it is independent of the distance. And as it is independent of the distance, what we can say? Uniform. What do you mean by uniform? Everywhere your electric field is same, uniform. So this is your second question. Now the third question, they can ask you, draw electric field versus distance graph. Draw electric field versus distance graph. And as it is uniform, and what do you mean by uniform? The value is constant. And as the value is constant, so you can write constant. Now, this is the third question. They can ask you. Now the again fourth question, and believe me, CBSE board already asks this type of question so many times. So these are very, very important. You can write it like a coming soon. Now they can ask you again, A and B are two position, Q charges moving from this to this. Find the relation between force at A and force at B. Again you can write this distance is RA, this distance is RB, but here uniform electric field, so it does not depend on position. So what we can say, electric field at A and electric field at B is equal. Now charge into electric field at A, charge into electric field at B, force at A equals to force of B. That is the one part of the question. Again, one more question. See, same, we can compare it with the last one. Here we have R, suppose here we have 2R. So then they ask you, find the ratio between the force at A and B, or B by A. Please don't confuse. The last one, it is inversely proportional to distance, but this one, it is not depend on distance. So what we write? QA, QB, A by B equals to 1. Why? Because electric field at A is equals to electric field of B, because they are uniform. So again, from one topic, how many questions arise? 6 questions arise. And you don't confuse that last one is depend on inversely proportional to distance, but this one is independent of the distance. Now after that, they can ask you electric field lines for parallel plate, and this one is very, very important for your second chapter also. Here we just try to draw the graph, and why these things happen we discussed in that chapter, in the second chapter, capacitor. And this question, you don't believe, this question in 2000, this question is asked in IIT screening. So you understand how much important these questions are. This one is plus charge, this one is minus charge. And actually in this two side, means you have the two parallel plate capacitor like this. So this two side, no electric field is there. Why? Again we explain it on the second chapter, means in capacitor. But here, see, this one is positive charge, this one is negative charge. We have to draw the electric lines of force. This one is plus to minus. And most of the students draw up to that part, but at the end, it will be bent. So in exam you have 4 options. One option is this one option is without that. Next, so you have 2 options, and next 2 options they just reverse it. It will be moving from negative to positive. So the option is this one is the right option. After that, next very, very important one. After that, very, very important one is draw electric lines of force. Draw electric lines of force for metal surface. Draw electric lines of force for metallic sphere. So this one is your sphere, metal, and we know from the definition of properties of electric lines of force, electric field inside the metal is 0. Now if we consider the whole surface is positively charged, so whatever be the charge that is on the outer surface, and whatever be the charge that is on the outer surface. Why? Because according to the property, no electric field inside the metal. If you want to know in more detail why that one happened, again when we switch on to the capacitor, if we insert metal, what happened, then we discuss all these things in very detail. Now concentrate here. Sorry, I don't want to use that red pen. So this is the positive charge. Now see it properly. Okay, see it properly. This one is positive and we make this one. Now we make little bit curve. Why we make them little bit curve? Which indicates that they are normal to the surface. See this, and actually if you consider a sphere, actually this one is this. So you are not able to draw it three-dimensionally. So this 3 dimension converted into 2 dimension, and that curve represents that it is entering or leaving normally. Hope you understand this. What I want to say, they are entering or leaving normally. So this one is a metallic sphere. One more, the last one, which is also very, very important. Draw electric lines of force. And it's a very, very interesting also. Suppose we have a parallel plate, means one plate is positive, one plate is negative. So many charged particles are there, means plus charge then minus charge. And these 2 plates are like this. These 2 plates are like, I will try to explain it. 2 plates are like this one and this one. 2 plate is there. One is that one is that one. So 2 plate is there. When you see it in the 2 dimension, it will look like this. Two side, 2 plane. Now you are insert a sphere. So as the upper one is we consider here positive, so what happens, due to that positive one, electrons are attracted by the upper one. So this one is the negative part, and the next one, as all electron clouds are shifted in that side of is deficiency of the electron, and deficiency of the electron means positively charged. And if you see one more thing, if this one is minus Q, this one is plus Q, overall it is neutralized. Now if you want to draw the graph, see from plus to minus, they are not touching each other. Negative to positive, again positive to negative. So it's like a real beauty. That's why I love that subject very much. So how it looked like? It looked like a half mushroom of the upper one and half mushroom of the lower one. Hope you understand this up to this part. My next topic is okay, so my next topic is find electric field at point P, which is at a distance x from the center of a Q carrying charge whose radius is r. The question is find electric field at point P due to a charge carrying circular ring. The amount of charge is Q and radius is r. And see, so this one is a ring. If we put it like this, so it will look like a circle. But here it will look like a ellipse. Why? Because we put it like this. So as we put it like this, so you see just the one part, and if you make it a little bit turn and take a snap, so it will be look like this. So it's not a ellipse, it's a circle. Okay. So now P is the position which is at distance x from the center, and we have to find out the electric field at point P due to that charge particle. So let we consider a small elementary part and let the amount of charges there dq. Now from that point, if we take a tangent, so the distance is x square plus r square, and we know for positive charge the direction of electric field away from the charge particle, so we make it move in that direction. This is the direction of electric field, this is the axis, so let this angle is theta, we can suppose this angle is also theta. So now we all know along the base is cos, so we can write dE cos theta, and this is the perpendicular with this, so we write dE sin theta. Similarly for the lower one, if we consider a dq amount of charge, so what happened? This is moving in this direction, again theta, this one is theta, so again this is dE cos theta, this is dE sin theta, and if you notice it, not only in this two, so many lines, it look like a cone, it look like this, these all are the same slant height of a cone, so these all are the same distance. So and for each component because it's a continuous, for each component dE you have one dE cos theta and dE sin theta. Now if we consider it as a half of the upper one and half of the lower one, for each half upper one, electric field dE sin theta cancelled by each half dE, each component half. For the lower one, dE sin theta cancelled by the upper one. So how we mention it? You have to mention it clearly from figure, each component of dE sin theta for the lower half cancelled by each component dE sin theta for the upper one. Means each component upper half dE sin theta, each component lower half dE sin theta, they cancel each other, and every time dE cos theta towards this x-axis, they are additive in nature. So as they are additive in nature, how we calculate it? The best way is to integrate it. So we try to integrate it. So net electric field at point P, that is dE cos theta. So what is the value of dE? 1 by 4 pi epsilon naught. dQ is the charge particle, and the distance between this and this, x square plus r square, root ka square, so we have root and square cancel, x square plus r square. Now cos theta, what do you mean by cos theta? Base upon hypotenuse, so we write x square plus r square. For that half root we write this. So now we can remove the constant part, 1 by 4 pi epsilon naught x by x square plus r square 3 by 2 dq. Now here this all are constant, only variable is this dq, so we know integration of dx is x, so integration of dq is q. So finally we can write here electric field is 1 by 4 pi epsilon naught x dq, integration is q by x square plus r square 3 by 2. And if x equals to 0, what do you mean by x equals to 0? That P is moved on to that center. So we can write when x equals to 0, electric field at the center x is 0, that hole is 0. So we can say it, electric field at the center is 0. Sometime they don't give you in terms of Q, they can ask you in terms of lambda. So lambda is the linear charge distribution. Suppose lambda is the linear charge distribution. So what do you mean by linear charge distribution? Charge per unit length. So in that case, what is the charge on that ring? Lambda into circumference 2 pi r. So if we put it, so electric field at P is 1 by 4 pi epsilon naught x lambda into 2 pi r by x square plus r square 3 by 2. This cancel. So what we have, lambda x r by 2 epsilon naught x square plus r square 3 by 2. You can get the answer or the question or the solution in that manner also, and with related to that topic, so many that formula, so many questions asked in entrance exam also, like where the electric field is maximum, at what position electric field is maximum. Then you can find out if you put a charged particle here when it is simple harmonic motion, if x is very less than r, when find the time period of oscillation. They can ask you this type of question also, although that is not in your board part, means board syllabus part, that's related to entrance exam. But if you try, you can try it. Okay, so that is our first class. Next, in the second class, we switch on to that very important topic, Gauss's theorem. And until tata, have a nice day and stay at home.